Last time we looked at the if then else statement, and the point of the else was all other conditions that were not true will just automatically go to our else. Turns out some questions cannot be answered with a single yes or no question. And in those situations, we need to stack up several Boolean expressions, one after another, to try to cover all of our bases. And to facilitate that, we're going to look at this new structure called an if then else if. So instead of just having one Boolean expression, we can now stack up many Boolean expressions, one after another, and if none of them are met, we will still have an else, which is our catch-all. So the structure will look something like this. We have an if and then our first Boolean expression, all the statements that happen if this is true. If it's not true, we go to the next one, and then this is checked. This Boolean expression is checked. If it is true, our code moves in here, does these. Whenever a Boolean expression is true and we enter into the code section, when it's done, it does not go to the next one, it automatically goes right to the bottom. So we do our first check, our second check, and we keep checking over and over again until we enter in. We can have many and many of these, so that's why I say just n. And if none of the above are true, then we can have an else and it will come into here. So if we look at an example question, such as a traffic light, if you were a driver or you happen to be like a self-driving car and you come to a traffic light, you don't have a single Boolean expression question, you actually have several. If the light is green, go through. If the light is yellow, check and slowly go through. If the light is red, then stop. And you might even have other situations. Sometimes there's traffic lights that have a white rectangle, and that's so that public transit can advance, but nobody else is allowed. So that might be in your else. So this kind of situation, I'm going to break it down in our top-down design. So we're driving a car. We have an input process and the output. The input is get the color of the light. Our process is going to be, we're going to check the color of the light, and then the output, we're going to do one of several things. We might go, slow down, stop, or we might not be sure what to do if it's something else. In a flowchart, because we're having a series of Boolean expressions, every single Boolean expression will go into a diamond. So we start, we get the color of the light, and then we're going to check to see if it is a red to begin with. So if the color is equal to red, then we're going to come down here and we're going to show stop, and then we automatically go directly to stop. Okay? If it is not true, then else if, we come down here. And you can either put else if here, or you can just put if, either are acceptable. If the light color is equal to yellow, then you can show slow down, and then you end. Else if, you check to see if it's green. If it is, you go. Else, so this is your final else, then you just say, I'm not quite sure what to do, and then you would stop. In code, in Python, it would look something like this. We have the input from the user. It's going to be a string, and it's going to be held in a variable called light color. We check if the color is equal to red. If it is, then we're just going to print it out. ElseIf, so in Python, you don't actually print out all the else if, it's just ElseIf. Now we have yet another Boolean expression. If it's yellow, slow down. Else if, or elif, the color is green, then you go. And if it's none of the above, then we just print, we're not quite sure what's going on. So if we just test out our program, if we type in green, it will tell us that we're good to go. If we do yellow, it'll tell us to slow down. If we do red, it will tell us to stop. And if it's something else, maybe someone thinks it's blue, then we're just not quite sure what to do.